Welcome back to part 2 of episode 54 of our podcast, Inside Intel, Digital Twins, AI, and the Future of Semiconductors. Today, our guest is Attila Lengyel from Intel. So why don't we just jump right back into it? Now, with the complexity of chip manufacturing in mind, how can turnaround times from design to manufacturing be reduced using digital technologies? Here I'm thinking digital twins, artificial intelligence. As in any other industry, these technologies are being explored in semiconductor to some extent. But I'm thinking especially with the cost of manufacturing continuing to rise at a very rapid rate, as you described in the beginning of this podcast, how is that actually happening, that implementation? How can it impact the turnaround time?
Oh, thanks. This is really a good question. And of course, it aligns to the blueprint discussion. So let me start my answer with my favorite words. And of course, making my teams always anxious whenever they hear it. So my famous word is in theory. And when I start in theory, it's always means that my team knows there's a ton of work to be done, because it's easy to say in theory, but then bring it into practice is a whole another word. So in theory, we could model the entire fab and operation virtually and simulate it. Think about how simple statement is that. In theory, it's perfectly possible. Within our work currently at Intel, our digital twin blueprint consists of 4 key digital twins. And these are really the main assets in a semiconductor fab. So you need to focus on equipment digital twin. Then we have facilities digital twin, and we're focusing on process digital twin. And last but not least, we are focusing on logistics digital twin. This is a podcast. I can't really show the slide about this, but I think there are some slides around that I presented around. So as I have discussed, this really covers the entire digital twins of fab assets. They do provide digital models, they provide a digital thread, simulations, and of course interfaces to these assets. And I think these are really, really critical to have very well designed, as we discussed earlier in the blueprint. How do you build this? Of course, you have several commercial solutions to this, but sometimes you inject custom developed solutions where we really couldn't get the right capabilities. But I think it happens everywhere. But it's just, for us, it's just totally default to think about it, that we have to real-time monitor our entire facility assets to run the operations. And of course, whenever we see, like as I mentioned before, our spot robot from Boston Dynamics alerts that there is some noise that is anomalous coming off the pump. So we need to launch preventive maintenance. If you mention this, it's very clear and very easy. This standalone will not be anything new. But when you start to think about it, you can interface this data to the equipment digital or the process digital twins, and then you can automatically launch root cause analysis for quality and yield issues. It takes the entire thing to a whole new level. Think about, let's say, Spot Robots alerts that there is a pump issue, and maybe this feeds one of our edging tool, and then some of the lots were run during that. Then looking into the lots, whether it's being the process parameters where they're looking at the measurements, and then figuring out whether this pump caused any quality issues or yield issues. So think really in this way, that once you link all these digital twins together with all these capabilities, now you can really, really take everything to the next level. So I think digitalization and in sense digital transformation is really critical. Now, once you have these interfaces, and you remember I talked about architects, right? Architectural aspects. And this is what we need to keep in mind to enable AI agents. That means that we have to have access to the data. We need to run the workflows, make decisions, improving our product quality, yield, cost, and operation performances. This is really the way. It might be obvious and everybody knows it, but I think whoever tried to do this immediately understand these are very critical and difficult challenges to solve, because you do have to have that blueprint. You need to understand how you're going to build this out. And once you do that, you do need to, enable automation to load the data, to make decisions, observe those events and run workflows. These are very complex, especially when we talk about billions of dollars in investments in fabs. These are very complex tasks.
Oh, that's really interesting what you're doing with the digital twins. That's a topic you could probably imagine comes up pretty regularly on our podcast, and the way that you're interfacing them with each other really seems to maximize the benefits you can derive from them. Earlier, I asked a question about the future, and I'd like to do it again. What does the future of digitalization look like for the semiconductor industry? And I'll even borrow your statement. In theory, what needs to happen to make fabs and the industry more future ready?
We're now taking a brief break from this episode to briefly talk about a semiconductor web page that might be of interest for you. On this page, you will find videos, customer testimonials. We have information about predictive maintenance, FMCS, cybersecurity, all geared towards the semiconductor industry. So go find the link in the show notes as usual and go check out that website.
Great, I think. So I really believe, as I mentioned before, modular systems and open platforms are really, really important. And if you are within the semiconductor business, I think we have really good semi standards that our vendors and our automation teams follow. However, there's a lot of closed systems, closed platforms that we really need to look into and think about whether that's the right path to move forward. This is really a huge task. And of course, our partners need to follow and understand and work together. But it's been there for decades. If you look at the SEMI association that helps us to form these standards, form these interfaces. I do believe we need to continue in that path and thinking in small modules with open interfaces to communicate with digital actors, for example, like AI agents that can communicate with our digital twins bidirectionally. I usually like to talk about digital actors because not everything needs AI agents. Digital actors can be, an interface. Actually, you can be a digital actor using an interface, a human-machine interface, let's say next to the tool, clicking certain buttons and following workflows. But as we see right now, work will be more and more shifted to automated workflows and intelligent digital actors. I really see a great future with our agent-oriented programming, where we really build the systems from ground up, agents in mind. Agent interfaces instead of human interfaces. Let's say, for example, if we wanted our large language models to be able to translate an agent background or task. If you ever worked with agentic AI, you would know, how agent background is being described by natural languages, right? We are using natural languages to describe agentic AI task missions and backgrounds. Now, the programming languages, the computer programming languages need to be created through those natural languages, and our LLM might not be ready for it. So even if you tell some specific semiconductor-related terms, the LLM will not understand and it will not be able to translate into Python or any other automatically executable events. So we will need to train these LLMs that we use in our digital infrastructure that understands our architectures, interfaces, and of course, business context. So I think it's really important when we think about future ready to think about automated agents, automated workflows, think about, interfaces, think about the technologies that enable this ecosystem within the new fancy agentic AI. And those are large language models. So I think this is, again, another challenge. And we need to make and think about how do we create future-ready industrial systems that we think about the entire ecosystem and then we bring in recent tools and train and update them. Remember, there is no free lunch, meaning that we can't expect systems or AI agents or machine learning tools to know exactly what we think of if we have not talked about it earlier. So there is no free lunch. There is somewhere there is a catch, right? But the good thing that this thing's getting cheaper and much easier to prepare and access.
Well, Attila, we appreciate you sharing your insights and experiences at Intel with digital transformation. So we've asked you some questions about the future. So now what I'd like to do is look at the past. And in fact, the very recent past, some of your earlier statements. Could you summarize some key takeaways from our discussion for our audience?
Definitely, I'd be, of course, glad to. So let's just really summarize what we talked about, and I want to make sure that there is a very specific, learnings for the audience from this podcast. So I truly recommend creating a future-looking moonshot for your digitalization goals. A vision where you know what your business and how will your business will thrive in. It's really important this moonshot needs to resonate with the entire organization so that really you can get buy-ins and you can work together. Then once you have this moonshot and that everybody really understands and works toward to, then you need to create a lot of hypotheses why you're not able to do these and what kind of capabilities you need. And this phase is truly called possibility thinking. An example like, if we don't have a rocket to go to the moon, we will not be able to go to the moon, so we need a rocket. But then, other question, our hypothesis and our capabilities need to be coming through. Let's say, for example, as I said, if our spot robot wants to kick out a quality excursion analytics, then we need to interface, we need to design this, and we need to make sure that it happens. So this is really what I think about possibility thinking. You really need to know how that capability would incrementally improve your business. It's not just creating a rocket. SpaceX is a really good example, with the Starlink. As they trying to get to the Mars on the way, they do incremental business improvements for the world, and that's how they really make it financial viable movement. So that's really what I think it's important. Of course, you need to use trial and error to discover roadblocks, and you need to work on removing that. Innovate by removing these roadblocks. Don't get discouraged. Learning, and in this way, it actually gets translated into knowledge. It worked in A, it didn't work B, so you learned that B is not working. So that's already saving you time so that you can look for other opportunities. You can look for other learnings. And on that learning path, you will have really surprising findings. In the future, we do know that work will be done with digital actors in the future. Some like to call them AI agents. I like that. I studied and learned in my PhD in agent-based systems and how we create those simple interactions with actors to create very complex behaviors. So we do believe that more and more work will be done by agents. Of course, to be able to do that, you need to think about not just human-machine interfaces, but machine-to-machine interfaces. So you need to make sure all your assets can work with these agents that are coming. And lastly, it's always important about business improvements. So think of workflows that enable business improvements. Think holistically. Don't try to compartmentalize your thinking in just few little elements of the business. You really need to think about entire workflows that run a business process and how it can improve. Generally, every business test can be broken down into a certain inputs. You have an algorithm and you have an output, and these things feed each other. Think about how to build a complex process. And from these small, modular, and open actors, how do you orchestrate an entire business process that in the end results in improvements? Don't think that there is one magic, monolithic, super algorithm that can solve your problems. That's, I think 30 years ago, we did believe that, there is some super magic algorithm that will optimize your entire fab by clicking of a button, and then you would launch huge compute mathematical optimization and that will solve your problems. That's not exist. I don't believe in that. I do believe that success will be a synthesis of small, intelligent actors, humans or digital.
That was a very nice way to end your list of great pieces of advice, Attila. I appreciate that really much, and I'm sure our listeners will find it useful, especially for those interested in implementing digital technologies, whether their industry is as highly complex as is the case with semiconductors, or if it's an industry with, let's say, more simple manufacturing and process steps. Manufacturing in general is developing at the speed of light these days. It feels like with all these digital technologies being introduced, implemented, and we're starting to see some learnings from it. So really, really nice set of takeaways there. With that, we want to thank you very much for being on the podcast. It's been a great pleasure talking to you today.
All right. Thank you very much for this opportunity that we can discuss this topic here. It's really an honor to be with you here. Thank you. And, I really hope that as we move forward and we can talk more and more about our achievement in this field, how we're building these digital architectures, digital twins, and AI agents during our digitalization and digital transformation. Maybe later on I can give you an update and we can discuss our progress.
That would be awesome. We intend to stick around for many more episodes. This is the 54th episode, so we've had some longevity. We'll continue for another 50, and it would be awesome to have you on again in the future to see where you are. Intel is with the progress. It's always interesting to kind of follow along. So I might take you up on that, Attila. With that, we're at the end of this episode. If you have any questions about any of the topics that Attila discussed today, please feel free to reach out to him directly. We have included a link to Attila's LinkedIn profile in the show notes, so go there, click on it, check out his impressive resume, and feel free to reach out, either connect or send him a message if you would like to continue the conversation with him. And as usual, Don and I are always open to your comments, any thoughts, any feedback you might have on the show and on the topics. And you can, of course, as usual, also find our contact information in the show notes. We'd love to hear from you. So if you liked what you heard today, please help spread the word by rating the show. And if you are not already a subscriber and would like to be notified when new episodes are released, please subscribe to the series. Thank you for listening to this episode 54 of Digitalization Tech Talks.